Hi everybody, welcome to our today's meetup, the May 2021. As always, presented by .NET Devs AT. That's wrong. Yeah, who we are. We are a non-profit organization here in Vienna, Austria, about supporting and sharing knowledge about the .NET ecosystem. We have a website. We are on Twitter. We are on Twitch, as you can see right now. We are on YouTube. Hello to the two viewers from YouTube. We also stream simultaneous to both, to Twitch and YouTube. And we have also a Slack group where we help each other out. And I will post all the links in the stream. All the links in the chat. Sorry. Yeah, thank you all for joining today. Will be an interesting talk from Fabian. But before we come to that, thanks to our sponsors, thanks to OGS Software and Services, to every Rubicon, and also to the JetBrains, who is sponsoring one 12-month license of one of the products. We will raffle them. If you take part in the feedback form, you will then have the chance to win one of the licenses. Some quick news from the community. This meetup is part of the .NET Foundation, the .NET Foundation Virtual User Group. It's a lot of user groups around the world are announcing their meetups also there. So probably a lot of you have found us this way. If you're interested in content from all around the world, join this meetup group. If you don't happen, always a cool, interesting stuff around the world. Yeah, some events. The microservices ecosystem meetup here in Vienna has on June 10th a talk about micro frontends, and also as far as I know, it's remote, so everybody can join. It's still everything in lockdown here in Vienna, probably also in June. And the second one is probably interesting only for the Austrian viewers. Microsoft are still running their cloud transformation workshops. They are free workshops, half a day about different topics. So if you're interested, register there. Yeah, and that was it from my side in the beginning. Now we have Fabian Schmied as guest today about asynchronous background processing in .NET with Hangfire. We are looking forward to it. I will monitor the questions in chat and we will answer them at the end. So post it there and I will ask Fabian at the end. And with that, Fabian, it is your stage.
Thank you, Andy. Can you see my screen?
Yes, and I can see me.
Okay, I'll close you. Okay, great. So this doesn't work. Several years ago, a new restaurant opened in Vienna. You might know it because it has or had several branches in several cities. I went there with a couple of friends because it had a then novel way of serving food. It served Italian food, and after entering the restaurant, you had to decide whether you wanted pasta or pizza. If you wanted pasta, there was a number of counters where you had to queue up, wait until it was your turn. Then there was a cook behind the counter, and you would tell them what kind of pasta you wanted. You could watch them prepare the food. Then you would get your dish, take your dish, and return to your table. This is what it looked like. If you wanted pizza, there was also a counter, but it was only one counter, and there was hardly any queue in front of it. And you went there, told the cook behind the counter what you wanted, and he would give you a buzzer. And you would take that buzzer and return to your table immediately. And after some time, the buzzer would buzz, and you could return to the counter and exchange the buzzer for a pizza. So, hi everyone, and welcome to my talk. My name is Fabian Schmied. I'm a software architect. I work at Rubicon IT. I work on the SignPath team. SignPath is a platform for code signing, so you can upload your build artifacts there, and we will apply digital signatures using a code signing certificate. I'm very interested in domain-driven design. I'm also a host of the Domain-Driven Design Vienna meetup. I'm also interested in command and query responsibility segregation and event sourcing, and I primarily work with .NET. You are probably watching this talk on your phones or tablets, laptops or desktop computers, either on Twitch and YouTube. And at the time I'm doing this, it's currently about 6:20 in Vienna, so PM. So you probably have, or many of you will probably have had a hard day already, and you might ask yourself how long I'm going to take. And this talk is going to take about 1 hour before we start Q&A. Andy already said, if you have any questions, please post them to the Twitch or maybe, I guess, YouTube live chats, and he will then ask them to me after the talk. Also, some of you might already have some experience with asynchronous background processing, maybe even with Hangfire. Others will have used other technologies, probably, but some might not have dealt with asynchronous background processing before. When we, as the SignPath team, had to implement one of our core use cases, which is the one where you upload your build artifact and we will sign it and then return you the signed artifact, we knew enough about asynchronous background processing that we knew we had to make a choice. We had to decide whether to implement this the pasta or pizza way. The pasta way means you would, as a customer who wants to sign something, create a web request and upload your build artifact with that web request. And then within the web request, we would sign your build artifact, and as a response of that web request, you would receive the signed artifact. The pizza way, on the other hand, would be you create a web request, you upload your build artifact as before, but we would immediately return from the web request with a token. And after some time, you would get a notification and you would be able to exchange the token against the signed artifact. And when we thought about this a bit more, we noticed that signing in our specific domain is actually a workflow, right? It starts by you submitting your build artifacts, and then we would implement something we call the approval process, where one of your team members or a supervisor or something would have to approve that you could use your code signing certificate for this build artifact. Then we would scan the build artifact for malware. Then we would maybe unpack the artifact if it was a zip archive, for example. Then we would have to sign the files and then repack the artifact. And if you think about it, depending on the artifact size, scanning for malware would take seconds or minutes. Unpacking would take seconds or minutes again. Signing could take seconds or minutes, and repacking would take seconds or minutes. But this human intervention step, where we would wait for approval by a teammate of yours, this would take minutes, hours, or even days, right? So there was no way to implement this within a single web request. And we knew we had to implement this the pizza way, and the pizza way is actually asynchronous background processing. So asynchronous background processing means that when your software has to do a job, has to process something, it will not do so right away. For example, within the same web request where this command to process something came in, but would do so asynchronously in the background. This allows you to implement what I just explained. You could have web requests that immediately finished without the client running into timeouts while the actual work was being done in the background. This is also called the fire and forget type of processing work. So you just fire the processing work like a rocket and then forget about it, and it will be dealt with in the background. You can also implement hour or day-long processes using asynchronous background processing with human interaction, like our approval process. Maybe processes that could run into errors and then need to be retried, or processes that need to run overnight because they take so long. It's also a good thing for periodic work, like some work that needs to be done every day at 3 a.m., for example, or delayed work, like something that needs to be done in 3 days from now. And finally, it's a good thing for offloading work from your web server. So if you have a lot of processing, the web server might not be the right place to perform that work. You might want to put this into another service which is running in the background, or some other, maybe even some other machine, right? This would be good for the scalability of your application, for the reliability maybe, and also maybe for security, because if the processing work is very sensitive, then you might not want to do this on the web server. And asynchronous processing allows for all of that. So just a quick thing about async or asynchronous. In the .NET world, there is, of course, a different kind of async. There's the async await kind of asynchronous programming. This is to avoid blocking threads, for example, while you're doing some input-output operation. The keywords there are tasks and thread pools, and of course, async await. And this is called asynchronous background processing, or something. Okay, I'm having an echo here. Andy?
Can you repeat about the last 20 seconds? I lost audio from you.
Okay, I'm still hearing myself.
Okay, do you have any stream open? Fabian?
Yeah. Does it work again?
Looks better as usual. I didn't change anything, but it looks. I'm hearing you better.
I can try again. What was the last thing that worked?
That we have something different in .NET was also called async.
Okay, so we have that async await stuff, which is for avoiding blocking threads, for example, during I/O, and it's for non-blocking UIs and scalable web servers. And it's the async await, which you have in C#, for example, and also I think in Visual Basic.NET. And then there's the asynchronous background processing, which is, like I said, to avoid blocking web requests, for example, for returning fast instead of having to do everything within the web request. It's good for long workflows, for overnight things, and so on, all the things I already mentioned. And some important keywords here are jobs, queues, processes, workers. And it's also used to implement scalable web servers, but it's also used to implement complex scalable distributed systems. And this is the one, is the kind of async that I'm talking about today, not the async await one. So the question is, how do you implement this kind of asynchronous background processing? And first, I would like to tell you how to not implement it. You do not want to implement this using Task.Run, ThreadPool.QueueUserWorkItem, or Thread.Start. And the reason you do not want to do that is because you have to ask yourself the question, what happens if the web server crashes? For example, consider that we had implemented that use case I talked about earlier using Task.Run or Thread.Start. And you would send us a web request and we accept it. And then we run all the work in the background using Task.Run. And then the web server crashes. And when the web server restarts, the job is gone, right? You will not be able to continue running it because Task.Run and Thread.Start are only in-memory concepts. And once the process is gone, once the web server has restarted, all the in-memory stuff is gone. So this is not something you want. And it's the same about the web server shutting down. If you have all your jobs in memory or your background processing in memory only, then then shutting down a web server becomes a really dangerous thing to do. And finally, these things do not allow you to scale and to offload work to other processes, services, or even machines. So a better thing to implement this, or the question is how then to implement this. And it's actually quite easy because you just need two things. You need a durable queue and a background worker. And with a durable queue and a background worker, it works like this. For example, our web server, which needs to get a job done, puts that job into a durable queue. And durable means persistent on disk or in a database or something, not just in memory. And then you have the background worker that monitors that queue, takes the job from the queue and processes it. And it will only remove the job from the queue after successfully finishing it. And if it's crashing while processing it, then the next time the background worker restarts, the job is still in the queue and it can again take the job from the queue and ensure that it's really performed. And background workers usually also implement some kind of error retry policy. So if something goes wrong, then the background worker will just retry the job for a number of times. And the background workers can, of course, also implement scheduling logic for periodic and delayed jobs. However, it all boils down to these two things, the durable queue and the background worker. So you probably don't want to implement the durable queue on your own. So it's a question of what technologies can you use to implement these two items. And for the durable queues, there's a lot of technology available. There's, for example, message queues like RabbitMQ. Some time ago, MSMQ, Microsoft Message Queue, was also popular, but this is no longer the case. There is Kafka, for example. There are cloud services such as Azure Queue Storage and the equivalents on Amazon and Google Cloud and IBM Cloud and so on. There are also higher level, more sophisticated queuing solutions like Azure Service Bus, for example, or maybe N-Service Bus. Or you can also just use a simple database and store your jobs in there. About the background workers, well, you can just implement a Linux daemon or a Windows service, for example, or just a simple console application that monitors the queue and runs the jobs. Or you could implement Azure functions, Amazon Lambdas, and so on. Or just to get started, you could even do background threads in the web server, because once you have the durable queue, even background threads in the web server can monitor that queue, and even if the web server crashes, they can continue running those jobs. Or you can just use Hangfire, which is what I'm going to talk about. But before I do so, let me just say one more thing about the asynchronous background processing stuff. One thing that's very different to synchronous processing is that you now need to know how or when to get the results. If you remember my pizza example from before, my pizza story from before, the restaurant would give me a buzzer, and the buzzer would buzz at some time, so I knew when to get my pizza. And it's the same about the software, right? You need to have some way of knowing when the background processing has finished. And I just wanted to give a few examples of how this is usually implemented. And the simplest approach that often works very well is simple polling, which means the client, the customer, whoever, just after some time, they try to get the result. And if they get the result, everything is fine. And if the result is not done yet, they try again after some time. And they retry and retry and retry. And at some point, the background processing is finished and they get the processing results. This is often good enough. However, it's not very sophisticated, and sometimes you need something more with better user experience, for example. Then you could use, of course, WebSockets or SignalR. These provide very good user experience. They are really sophisticated technologies. However, they are also much more complex than, for example, simple polling. And then there are completely different approaches to that problem. For example, if your if your clients are humans, if you just want to notify a human that something is done, you could just send them an email or a text message, right? This is also quite simple to implement, and it works very well for human recipients. And finally, if you are in a distributed system and you want to notify another system, another service, for example, that you are done with some processing, then a common implementation is to have a webhook notification. So you just perform a web request to that other system, and that other system then now knows that you have finished your processing work. And this is also quite simple to implement and often used for distributed systems. Okay, now back to Hangfire. Hangfire, what is Hangfire? Hangfire is an all-in-one solution to background processing. I've included a screenshot of the Hangfire.io website here, and I'll just go through it very quickly. It is for background processing in .NET and .NET Core applications. It uses persistent storage, so it has that durable queue. It is open source and free for commercial use. It supports these fire and forget jobs that I mentioned earlier. It has delayed jobs and recurring jobs. And it also has a paid version called Hangfire Pro, which includes a few more features and professional support. This is a picture I've taken from the Hangfire documentation page. It shows very well what Hangfire or how Hangfire works. And as you can see, they have a durable queue here and a background worker. In Hangfire lingo, these are called job storage and Hangfire server. And it works this way. As a Hangfire client, you can create a job at any time, and it will be put into the queue, into the job storage. And then Hangfire returns immediately. And the Hangfire server, which is the background worker, will in the background monitor that queue, fetch the next job, perform it in the background, and so on and so on. So Hangfire implements exactly those two components you need for asynchronous background processing. It implements the durable queue and the background worker. And this is a good point in time to do a demo of Hangfire. And for that demo, I've implemented a very simple version of that use case I mentioned earlier about that of that signing use case. And I don't know about you. Probably you will be using some IDE like Visual Studio, maybe with ReSharper, or maybe Rider. But I've decided to do that demo in Visual Studio Code because I don't usually use it at work, and I thought this would be a good idea to try out Visual Studio Code. So this is my Visual Studio Code here, and I have my demo solution open. The demo consists of two projects. One of them is a services project, which just has some fake implementations of this signing request processing I mentioned earlier. And the other one is an ASP.NET Core web application called Demo Web. And I'll just show you what it does. I'll go to my web browser. Oh, I have to do .NET Run first. Okay. I go to my web browser. It should load fine now. Okay. That demo application has 3 routes. The first one is a post action to signing requests where you can upload your build artifact and have it signed by this demo application. And then you will get a signing request ID back. Then you can get that signing request with the signing request ID. And once it's finished, you can also get the signed artifact, so the results of the background processing. And it works this way that I don't know if you know this Swagger UI. This is just automatically included by the ASP.NET Core template, and it shows the web requests you can make to my ASP.NET Core application, and I can also try it out here. So I will just click on the post, and I will click on try it out, and then it will allow me to select an unsigned artifact. I have a file here, call it It's called build artifact. And I will execute this post action, and you can see it loading here. And it's loading and loading and loading because I've not implemented this using asynchronous background processing, but this is currently being processed synchronously. Okay. I've implemented this in the demo to just do some fake work, but it takes exactly 20 seconds. And in reality, this might take a lot longer and might not be suitable for synchronous processing. However, after 20 seconds, it finished, and it's returning me the signing request ID and a location header where I can go to. And I can see here that I that I uploaded my build artifact txt, that the processing has finished, and here's a link to the signed artifact, and I can open the signed artifact, but because it's just a demo, it's just some dummy content here, not really something useful. It's just a demo. Okay. So what I'm going to do now is I'll change this to asynchronous background processing using Hangfire. And for that, I'll just show you how this currently works. I'll cancel this here and open up my ASP.NET Core web application. It has one controller that implements this post method I showed you earlier. And the post method, or that I executed earlier. The post method allows me to upload an unsigned artifact. It will then generate a signing request ID. It will store the unsigned artifact under that signing request ID somewhere using those services I mentioned earlier. And then it will tell an implementation of signing request processor to process that signing request with the given ID. And then it will return HTTP 201 created, indicating where to retrieve the result. And this line here is the problem, because this is what takes a long time. As you can see, this is implemented using async await. Right, as I mentioned, but as I mentioned earlier, async await does not mean that it's asynchronous background processing. It's still processed within the web request synchronously. I want it to be processed in the background and return fast from the web request. So I will add Hangfire to this project, and to do so, I will go to my demo web project, and I will call .NET add package Hangfire version 1.7.22, which is the one I tested this with. Okay, so I added the NuGet Hangfire package. And then I have to prepare something where Hangfire can store the durable queue. Right, I have to set up some kind of Hangfire storage. Hangfire comes with SQL Server storage. So I will just create a SQL Server database. I'll call it HangfireDB. And because I've executed this demo before on this machine, I will first drop the existing HangfireDB. I will execute this in my local DB instance. I have a local DB instance of SQL Server here on this machine, and I will just create this empty database in there. And it completed successfully. That's great. So now I have a database. And now I will configure Hangfire. I added a NuGet package, but I need to add a few configuration settings. First of all, I need to add the connection string, or a connection string, to the database I've just created. I'll call this connection Hangfire connection. And the connection string is server equals my local DB, MS SQL local DB, I think. I have to look this up again, sorry. Local DB, MS SQL local DB with a capital B. The database is HangfireDB, and integrated security is SSPI. So I will also enable logging for Hangfire. because if something goes wrong in this demo, I want to know where the problem is. Okay, this is all I need from the configuration point of view. And then I will configure Hangfire, or I will add the Hangfire services to my application. For that, I will go to my ASP.NET Core startup class, where it configures all those services. And I will just tell it to add the Hangfire services too. And for that, I will go to the Hangfire documentation. And under documentation, getting started, ASP.NET Core applications, we have a detailed there's a detailed list of things you need to do. I've already done that. I've installed Hangfire. I've just used the Hangfire meta package that includes these 3 packages listed here. I've created a database, and now I need to configure. Okay, I've already added the configuration settings. Now I need to register services. I'll just copy this over it to my configure services method here. Okay, it says services add Hangfire. I'll add the corresponding using statement using Hangfire. It says to configure a few defaults, data compatibility level, some serialization settings here again, also to use SQL Server storage. It says we want to use the Hangfire connection string that I just added. I need another using statement, hangfire.sql server. Then it adds some defaults again for some timeouts. These are things that they added in Hangfire 1.7. And for backwards compatibility reasons, you have to explicitly specify what you want. So the documentation lists all the defaults here. In Hangfire 1.8, they want to make all these settings the default again, breaking the background compatibility for Hangfire 1.6. However, it's easy to get this from the docs page. And then, so now I've configured all the services, so I can use Hangfire from my web application. And then I will also add the background worker, which is called Hangfire server, also within the web server, because I want to keep it simple for now. So all the background work will still be executed within the web server, just not synchronously, but asynchronously in the background. We can move this to another service process later on. Okay, I've now added the NuGet package, configured the connection string, configured all the Hangfire services and the background worker, and now I can use Hangfire to just to actually create a background job. And to do so, I'm going back to my controller. I've here got the method, the method call that takes so long to execute and that I want to be done in the background. So I will go to the top of my class and have an instance of the interface I background job client injected. This is a class provided, an interface provided by Hangfire. I'm adding the using statement again. An interface added by Hangfire that allows me to enqueue jobs that Hangfire will process in the background. I will use constructor injection to this to do this here. This is just ordinary ASP.NET Core dependency injection. I will add this as a parameter to my constructor. So the ASP.NET Core dependency injection will include this service into my web controller, so I can use it. And I'm going back down to the long-running method here, and I will just remove it. And instead, I will tell Hangfire to please enqueue a new job. The job should be executed by a signing request processor, as before. And the signing request processor should process asynchronously signing request ID. So this is the same code I had earlier. It's the same signing request processor, process async, signing request ID. Signing request processor, process async, signing request ID, but enqueued as a new job. And when I now save everything, okay, everything is already saved. We'll now save everything and say .NET Run again. And I'm going back to the Swagger UI again, and I will click on this execute button again. Then you will notice that it immediately returns with my location header here. And when I go to that location header, you can see that my build artifact has been uploaded. Processing has not finished. And if I click on that link, I will get a 404 not found because it's all done in the background. But the web request immediately returned. And if I poll for some time, then you can see that processing finished has now become true, and I can now download the processing result. So that was all that I needed to do to get that long-running action be executed asynchronously in the background using Hangfire. Okay, the next thing I want to show you is a really cool feature of Hangfire, which is called the dashboard. Hangfire includes an operations dashboard where you can see the jobs that are running in your system in the background, which ones failed and which one are in queued and waiting to be executed and so on. And it's really easy to install this, so I'll just do this here. I just need to go to my other ASP.NET Core configure method, the one where all the endpoints, the web endpoints are configured. By default, the controllers are configured, such as the controller that I just showed you. And I will just add endpoints, add a map Hangfire dashboard, and do the run again. And now I have this nice dashboard here. I'll zoom down a little bit. Enough. And I can see here a real-time graph, how many jobs are currently being processed, 0, because I haven't created any new jobs. How many jobs have already been processed today, 1, which was the one I showed you earlier. I have this list of jobs here where it tells me what jobs are in queued, 0 at the moment, scheduled, processing, succeeded, failed, deleted, awaiting. We have one job that has succeeded, which was the job to signing request processor process async that I did 2 minutes ago. It took a bit more than 20 seconds. And if I click on it, it will show me some code, what it is doing within that job. So it's getting a signing request processor from somewhere. It uses the dependency injection framework from ASP.NET Core here as well. And it's processing, it's called process async with the GUID of the signing request that was created. Yeah, and it succeeded, and it started after 108 milliseconds, and it took a bit more than 20 seconds. Yeah. So this was just one line of code adding this dashboard, and it's really useful. So I wanted to show that. One additional thing that would be nice to see is, as I said before, once your application is a bit more complex, you might want to offload this asynchronous processing to another process or even machine. And this is actually also quite easy to do with Hangfire. And so we will just try to do it now. For this, I'll create a new worker project. I'll call it Hangfire Worker. And I'll just do .NET new worker here. This will create an ASP.NET Core or a .NET Core worker service in this directory. A worker service is just a console application that performs work. So you can define what kind of work it performs, and we want it to perform the Hangfire job processing. So this should be our background worker process. Within that project, I'm doing the same things I did before. So I will add the configuration stuff. I'll just copy this over from the web project. App settings JSON. So my connection strings here. Oops. Where did it go? Here it is. My connection strings and also the Hangfire information logging configuration. Then I will add the NuGet package again. .NET add package Hangfire version 1.7.22. There it is. Then I will copy over from the startup class. I will copy over all these add Hangfire stuff, and I will also copy over my own add demo services because we will need them. So I'll go to that newly created Hangfire worker project. This is structured a little bit differently from ASP.NET Core applications. It has no startup, but it has a program class, and within the program class there is also a configure services thing, and I can add these Hangfire services and my own demo services in this class. I need to add other using statements on my own because for some reason Visual Studio Code IntelliSense doesn't work correctly in this file. So I will just, it's probably rather the inspections. Okay. Hangfire SQL Server, and also my own demo.services. And I also need Microsoft Extensions configuration here. Okay. So I'm adding the Hangfire services. This configuration comes from a different place in a .NET Core worker service project. So I'll say host context.configuration here, and everything else should be fine. Okay, so I've now duplicated all the Hangfire setup here. I've duplicated the connection string, and now I will move the Hangfire server, which is set up for the worker process. I will remove it from the web application, and I will paste it to the worker service. Okay, and then I will split my terminal here. I will just build everything. Let's see if I didn't make any mistakes. Yeah. Okay, everything is fine. I haven't made any mistakes. Now I will run first. First, I will just run the demo.web project, and I will now. This is just this no longer has a background worker inside. So when I execute this again with my demo file here, execute it. Then it will immediately return, and it will also give me that location header, and the Hangfire dashboard will show me that I now have one enqueued job here, which is the job I just enqueued a few seconds ago by clicking on the try it out button. But it will not be processed because there is no worker running. It's telling me there's no Hangfire server because there is it's orange, and it's telling me there are 0 servers because I haven't started my worker yet. And now I'm starting my worker too. .NET run project demo.hangfire worker. Oops, what? Services does not exist. Oh, I forgot to add a reference to my demo services project. .NET add reference demo services. I need this because the Hangfire worker needs to execute the signing request processor, which is actually in the services project. So I'll add a reference to the demo services thing. Okay, try again. .NET build. .NET run this one here. Okay, now it's running, and now it should have taken that job, and it's now processing it. And processing finished is still false, but if we wait for another, I don't know, 10 seconds or so, the job should probably move from processing to succeeded. And now it says true here. And now I've offloaded the work from my web server to a background service. yeah, that's it for my demo. Let's go back to the presentation slides and let's just do a short recap of what I just did. I first decided upon the storage for my durable queue and created a database. Then I configured and used the background job client. I added the Hangfire NuGet package to my web application. I configured the connection string. I configured Hangfire using the add Hangfire method. And then I was able to use iBackground job client to enqueue jobs. And that was all I needed to do to get some asynchronous background processing. But we also configured the Hangfire dashboard by just calling the map Hangfire dashboard endpoint mapping method. And we also configured the Hangfire server in a separate project by also adding the Hangfire NuGet package, supplying the connection string, and then again saying add Hangfire and also adding the add Hangfire server method. So I think you will agree that this was a really simple way of getting a job being run or getting work asynchronously processed in the background. However, it's not all just rainbows and unicorns, so I'll do a quick evaluation of the pros and cons of Hangfire. It's the pros. It's all in one, it's no technology mix. This is a great advantage and it makes it really simple to set up. It's very flexible about hosting that background worker. You can do everything within your one web server or multiple web servers, or you can move it all to one or more background worker processes if you want, as I did in the demo. It supports the fire and forget types of jobs where you just fire the job and then forget about it, like I did in my web controller, where I just told Hangfire enqueue that job and then I want to forget about it. It also supports delayed jobs, which run after some time, and also recurring jobs, which run, for example, every day at the same time or every hour. It also supports multiple queues, which is an important thing if you want to distribute your work evenly, maybe about, or you want some of the work run, for example, inside your web servers and other work in another worker processor and so on. You can use different queues for that, which is quite nice advanced use case. It has that dashboard I showed you. It integrates really nicely with SQL Server if you already have it. It works great with Azure SQL as well, so you can use it in the cloud. And it has an extensibility mechanism, which is also used by the community, for example, to add other storage mechanisms. For example, I've seen there is RavenDB storage, MongoDB storage, and others, PostgreSQL, I think. So there's also a community extension for that. And of course, it's free and open source. However, there are also cons. Because it's all in one, it's less flexible. You have less control over what's going on. The feature set is a bit limited. For example, apart from the features that I already mentioned, job prioritization, for example, if you want to say my jobs are, some jobs are more important than others, or some maybe jobs from certain customers are more important than others, then it's not that great. It doesn't have the right features for that, really. I think there are some extension points are missing. It's not easy to replace the serialization mechanism, for example. It also always uses JSON.NET per default with some settings. And if you want to tweak this, it's not that easy as it could be. There are some features that are only available for paying customers because of that Hangfire Pro product that you need to pay for. Good support is only available for paying customers. Out of the box, Hangfire only supports SQL Server and Azure SQL. For the paying customers, you also get Redis support by default. But for all the other storage options, you need to use the community extensions, which might not be as mature as the storage mechanisms that come out of the box. It also has no integration with other queuing systems. For example, it has no integration with Azure queues or the Amazon queues. And the documentation isn't that good on some advanced scenarios, like, for example, how to do job versioning. So this is my evaluation. we are using this in SignPath. Actually, we are actually using this in SignPath, and we are quite satisfied with it. However, you should know what you're dealing with before you decide to use it. So I think this is important to think about the cons as well as the pros. I would like to share a few learnings that we had in SignPath with Hangfire. And the first thing is that versioning thing that I already mentioned. And I think you should think about job versioning before going into production. And I'll tell you what I mean by versioning. If I go back to the controller where I created where I enqueued that job here, as you can see, I'm enqueuing a job that is situated on dealt with by iSigning request processor, and it's called process async. I'll go to that interface definition. So this is my iSigning request processor interface, and it has that process async method, and it takes a single GUID parameter, signing request ID. If I wanted to change this method, and after I went into production, then my Hangfire storage, my queue, will already have some jobs with that interface in production, right? So if I just change this, for example, to be a string instead of a GUID, then after I deploy the new version, Hangfire will not know what to do with the jobs that are already in the queue, right? Because the jobs in the queue want to pass a GUID, but now it takes a string. And Hangfire will just say, oh, I don't know what to do with that. I'll just throw some errors around. And that's why you need to have some versioning strategy. And what we do is we always support multiple versions. So if we if we want to change this, we don't actually change it. We add a new version of this process async method with the string parameter, and we just tell our teammates that this method here, the first one, is obsolete and should no longer be used. Only use this one from now on. But we will keep this in our code for as long as there might be jobs in the queue, jobs in the storage that use this old version. And this is something you need to think about before you go into production. So think about your versioning strategy before going into production. Then next item, use dedicated simple job interfaces. What do I mean by that? My job, I'll remove the string version again. My job has a very simple interface here. It's just a method with one single parameter, which is just an ID. This is a good job interface because there is very low likelihood that I would need to change to refactor this. So I would not have to create many versions of this job interface. When we started, we actually built job interfaces that took lots of parameters, and this created a lot of refactoring pressure where we wanted to change something, and then we had to still keep the old version along for as long as there might be jobs in the queue, and this was not a good thing. So we've decided to keep our job interfaces very simple as possible, so we don't have to refactor them so often. Then next thing, as I said, Hangfire has a feature for delayed jobs where you can schedule jobs into the future, and it's always for the same reason. We've decided to not schedule jobs too far into the future, because assuming that I would create a job that is running, for example, 3 years, then I would need to keep this piece of code in my code base for at least 3 years, because after 3 years, Hangfire would try to run the process async method with the GUID parameter, and if I changed my code in that time frame, and 3 years is a long time frame, so lots of changes might occur, then it will not be able to run this job. Therefore, yeah, we have decided not to schedule jobs too far into the future. For example, 3 days is okay, 3 years is not okay. And we've decided to use another feature of Hangfire instead, which is called recurring jobs, which are jobs that run, for example, every day. And we do exactly that. We run some jobs every day, and they will see if there's something to do. And for example, one of these jobs that runs every day will see if there is something that would run in 3 years from now on, and do that work instead of having a job scheduled for such a long time into the future. And finally, another tip, if you're using Hangfire, use the type name resolver feature. When I said that the Hangfire stores these jobs in its queue, it not only stores the name of this method and the signature of these the parameter types, but it also stores this name and maybe also the name of this DLL that's created here, this assembly that's created here. And if I rename any of those, it will again have problems with running the jobs. So to be able to, for example, rename this namespace, if you want to restructure your application, Hangfire has a feature that is called type name resolver. And using that feature, you can tell Hangfire, if you change this name, for example, you can tell it, oh, I changed this name, but if you encounter a job that has this name, then it's really this one, right? We discovered that feature, and it made our life a lot better because we can now refactor our code better than we could before. So these are 4 learnings that I wanted to share with you that we had while using Hangfire in SignPath. And I just want to say, if you want to work on this kind of system, you can take a look at signpath.io/jobs because we have a few open job postings. Yeah, one final thing, something that's not related to just Hangfire, but actually to all queuing systems that implement asynchronous background processing. If you remember earlier, I said that one cool thing about asynchronous background processing was that if your worker process was shut down or crashed at some time, the job would only be removed from the queue after it was finished successfully, and would be rerun if it crashed before being removed, if the process the worker crashed before the job being removed from the queue. And this is a cool thing and good for reliability and robustness and so on, but it also means that your jobs might be executed multiple times, right? Because if your job finished successfully and then Hangfire crashes, the worker process crashes just before Hangfire could store or could remove the successful job from the queue, then it will still be in the queue, and Hangfire will run it will run it again the next time. This is called at least once behavior. So these queuing systems, implementing those durable queues, will guarantee that each job is run at least once, but not exactly once, which means that you need to make sure that your jobs can deal with being run multiple times. This is called making your jobs idempotent, and it just means deal with them being run multiple times. For example, in SignPath, to take this example again, we have implemented some logic to if this process async method is run multiple times, then we will just ignore results from later runs. If we already have a completed result, then we will just ignore results from later runs. Yeah. And yeah, that's more or less it. If you want to read up a bit more on these topics, then I can recommend a blog series that Stephen Cleary wrote started in January 2021 on asynchronous background processing. He calls it asynchronous messaging, but it's actually the same thing. So if you're interested in this, read this blog series. It's really good, and it does not talk about Hangfire at all. It just talks about the basics of asynchronous background processing. If you're interested in Hangfire, I can recommend the Hangfire docs. They are really good for getting started. As I said earlier, they are missing a few advanced details, but they're really good for getting started, and they explain how Hangfire works and how you need to configure it and so on. Yeah, and about that pasta or pizza story from the beginning, I chose pasta that day because I liked that dish more. However, my 3 friends chose pizza, and I had to wait in the queue for a long time while a lot of people in front of me were waiting for the cooks to finish their pasta. And I could watch my 3 friends sitting at that table, talking with each other, having the buzzers lying on the table. And I wondered if the pasta way of serving food was really the most efficient one. And yeah, that's it. Andy, have you got any questions?
Yes, we got some. So, going through them in order they were in the chat. So, any tips or recommendations to run Hangfire applications as Windows service using like
Yeah,
Egypt's Top Shell will be a
yeah.
great help.
Yeah, we actually are currently running Hangfire either in a container as a Docker container as a console application, or we are also running it in Windows services, and we are using Top Shelf, just as you said. It integrates quite nicely. I'm not sure if there's not a lot to say about it. Just it works really well. Yeah.
Yeah, Top Shelf is amazing for Windows services. Good. Next questions. What reason would cause to prefer Hangfire instead of background tasks with hosted services in ASP.NET Core? Except, of course, post recycling, crashing, and recurring planned like cron tasks.
Yeah, it just has more features, and it has that durable queue, right? Your background workers need some way to store the jobs they need to do, and Hangfire has that out of the box. You can also use another technology, of course. You can use, I don't know, Azure queues, for example. But that's okay. That's a good thing. Just Hangfire has it all in one.
Okay, cool. Next question is what is the biggest reason to use Hangfire instead of rolling your own?
Yep. I think the biggest reason is that rolling your own is not that easy, right? If you have some technology that is really good, really well integrated, like for example Azure Queues and Azure Functions, for example, then rolling your own is also a simple thing. But if you don't have these kind of technologies, and if you just want to do, for example, a top-shelf Windows service and implement your own durable queue and background worker logic, it's going to be difficult to get it right in all the edge cases, with all the error cases, and with all the performance characteristics you might want to have fulfilled. For example, only a certain number of worker threads, and I don't know. It's really sophisticated to build a queuing system, to build an asynchronous processing system. And I wouldn't roll my own. I would use technologies that support it. For example, as I said, Azure Functions and Azure Queues, or Hangfire.
Good. So, next question is do you know if there is support for SQLite?
There is a community extension for SQLite. I think I saw it. We can look it up. It's on the Hangfire homepage. So it's
I would be surprised because, as far as I know, SQLite only likes one thread writing at once in the database. So
is that so? Okay, maybe I'm mistaken, but I thought oh no, it was LightDB. Sorry, no, it's SQLite. Yeah, it's here.
okay.
There is a SQLite storage, but it's only version 0.3. I'm not sure how mature it is. You would have to
for
to try this
small,
out.
perhaps I wouldn't expect high throughput.
Yeah, but there are some, for example, MySQL storage seems to be more mature. Yeah. If you already have a SQLite, for example, if you want to do it in memory, well, Hangfire has an in-memory storage out of the box for example, unit tests and stuff. So if you were thinking about using SQLite as a testing strategy, for example, I would probably use the in-memory storage instead.
Yeah.
It says memory storage here, but Hangfire also has an in-memory storage out of the box as well. Yeah.
Good to know. So, next question is not sure. Why Hangfire and not RabbitMQ, for example?
Actually, I don't know RabbitMQ well enough to answer that question as an expert, but I think RabbitMQ is a very good queuing solution. Lots of people are using it all over the world. So if you have, for example, if you need to have communication over different programming languages, over different platforms. For example, if you want to communicate between .NET and Java, for example, then it's probably a good solution. Hangfire is a very simple solution for a very specific platform. It's just .NET and out of the box it's only SQL Server, but there are of course these storage extensions. So I think it's just for .NET people it's just much easier maybe than RabbitMQ for getting started and for going a far way. Yeah.
Good. So one last question from chat that came in now is, so Hangfire is more beneficial on premise than in Azure.
Not necessarily, because for example, SignPath runs on Azure, and we are using Azure SQL for other stuff as well, and so we also use Hangfire with Azure SQL, and it works super. Yeah.
Good, and then we have now one question again. Question is of Hangfire is so probably Hangfire is not best fitting for fat client applications lacking lean SQLite storage.
I'm not sure I understand that question.
The question is what do you
What
is for
was,
you a fat client?
Yeah, I think it's probably related to that other question before, whether it had SQLite storage.
Yeah.
I think Hangfire is a good thing for fat client applications. I always mentioned web requests before because that was my working example here. But of course, asynchronous background processing is a great thing for fat client applications as well. And if your client is implemented in .NET, then Hangfire is also a good thing. If you're using SQLite, well, as I said, there is that extension. It's only version 0.3.0. I have no idea how mature it is. You would have to find that out on your own. Yeah.
Good. Fabian, that was the last question from chat.
Okay.
So, I take over. There's my mouse. Thank you, Fabian, for giving us the talk today. And as every speaker on our meetup, I will send you one of our custom coaster with our logo.
Okay, great. Thank you very much.
Everybody gets one who is speaking. Also, a lot of thanks and great presentations in the chat for you. Yeah, and also thank you. Okay, it's the wrong order. Thank you all viewers for joining us today, and thanks to our sponsors. And yeah, one of our sponsors is Rubicon, where Fabian works. We have also OBS software and Theater Every, and yeah, JetBrains, the license. We have quickly shared the link to the feedback form where you can take part in the raffle. If your company or you want to sponsor us, let's talk. We find something. We have on the website some general informations, and there are all suggestions. Talk with us. We find a solution. And yeah, the future. So we plan for June 2021. Our Microsoft Build After Conference talk show. MS Build conference is end of May, and we will have some guest speakers where we talk about the stuff that gets announced. And in July we have Brandon Minnick from Microsoft, and he will talk with us about .NET MAUI, the UI framework. Yeah, please spread the word that we are doing this monthly meetups. Invite colleagues, friends, customers. Retweet our stuff. Follow us on .NET Dev. Invite everybody. Again, quickly the links where you can find us. Yeah, homepage, Twitter, follow us there, Twitch and YouTube to watch the streaming and the recordings. Recordings should go up in the next days, when I find time, and we have our Slack group where we'll help out each other. And now, the promised link to the feedback form. We want to make these meetups better, and for that we need feedback. Also, our speakers like to get feedback how the talk was. So if you could quickly fill it out, and at the end there is then the part where you can say you want to take part in the raffle of the JetBrains license, and yeah, we will draw then some lucky winner who gets the license code. Good. That was it for today. I wish you all a happy and fun rest of your day. Some more, some less hours left today. And I hope we see us again in June. Stay safe and bye.